Hi everyone. Today is Wednesday. And if you have not submit your homework tag, you can submit tonight. Okay, everybody? When is our exam 3? Friday. So you can come here around 9:51, and then so we can come in and start the exam earlier. And I told you I teach another class here at 11. So if you need a couple more minutes, feel free to stay longer. So after you finish your exam, you just come here and submit it. Is that clear, everybody? So time is not a problem. All right. So this exam is about session 4.1 and chapter 5. Have you finished the practice exam? Yeah? How about other students? Okay, so you want to do well on this exam 3 as well, right? So go to the bottom here. This is the practice exam 3. So first finish it using pencil. And then this is the solution. But instead of just looking at the solution, I hope you can watch the video session recording. Is that clear, everybody? So I go over each problem in details in this recording. So you can pause every step to think through the math. Okay? And if you still have questions, you can ask me this afternoon or tomorrow. So please watch this recording by tonight. Then if you have questions, you can still ask me tomorrow. If you don't watch tonight and watch it tomorrow, if you have questions, you don't have time to ask me. Okay, everybody? So try our best. I want to provide all the resources for you, but you are the one who eat the food and digest and gain weight, right? I like cook it. I cook the food for you. You're the food, so eat it. Okay, and this is the formula for exam 3, right? And then this is the answer. Have you already filled out the formula sheet and memorized it? Okay, so please do that. All right. Yes. Okay. If you have questions, you can ask me this afternoon or tomorrow. Tomorrow afternoon I have a math department meeting. Okay, but from tomorrow morning I should be in my office. And also you can email me if I'm not in my office. Okay, we can also like meet virtually. Okay. Any questions about that? So before we start chapter 6, do you have any questions about like chapter 5 or anything? No? All good? Okay, great. Oh, by the way, do you receive my email about the class evaluations? Yes? No? But maybe search your spam box. So search class evaluation. So I give you extra credit for the class evaluation. This is how it works. Because I cannot see who submitted the evaluation and who wrote and something, right? I can only see the overall response rates. So if the overall response rate is 90%, then everybody in this class will get 0.5% extra credits. If overall response rate is 80%, then everybody, yeah, 0.5%. And 80% corresponds to 0.4. And then 70%, everybody get 0.3. 60%, 0.2. 50%, 0.1. So this is the extra credits.
So if everyone does it, we all get 1,000 points.
0.5%. So total is 100%.
So there's no increase if we get 100%.
It's hard, 100 is 0.5, at most 0.5, yes. And don't forget that if you have been taking your notes, you can show me your notes next week, then you will get 1% bonus. Okay, so that is the note-taking bonus. So show me your notes next week to gain the bonus. If you show me on Monday, and then you only need to include the notes up to Monday. If you show me Wednesday, you include all the notes up to Wednesday. If you show me Friday, you need to include all the notes. Okay, everybody? So, and try not to miss any example. If you miss a class, go to our website, the notes with the answers, fill those out. Because if you miss one example, you will lose point one. So if you miss 10 examples, then you don't get any notes bonus. Is that clear, everybody? And also, we have attendance bonus. Remember, you cannot miss more than 6 classes, but if you miss no more than 2 classes, you also get attendance bonus, which is 1%. So altogether, it's 2.5%. And you know, 2.5% may help you to increase your grade. And for some of you, you still miss a lot of homework. Practice exam and exam correction and refer. So I give you homework and practice exam and exam correction and refer to help you to increase your grades. Because those 10%, homework 5%, self-assessment 5%, you do it, then you can get 10 points. Right, everybody? So if you haven't do it, please submit that as soon as possible. Because I don't want, because the last day I accept late work is next Friday. I don't want you to submit like the Thursday night or Friday. Because if I grade your work, if I see you miss something, I can let you know you can resubmit to gain the points back. For example, sometimes a student forget to estimate the total score in the practice exam. That's why the student lose 1 point. Or the student only submit the exam record but didn't submit the exam correction. The student lose 5 points. So you can resubmit to gain those points back before the absolute deadline. Questions?
Is the practice exam for the final?
Oh, it's due on the Monday.
It is open though?
Everything except this. Okay, the practice exam is due on Monday.
I know, I was asking if we could access it now.
Yeah, you can. Oh, it's posted at the beginning of the semester.
Oh, okay.
Yeah. Right. Okay, so please do submit your work as soon as possible. Do you want those 10%? Yeah, you want those. They can help you to move up a grade. Okay. And right. So any questions? Good. Okay. So let's see. All right. So chapter 6. So this is the last chapter that we cover. So system of equations. Have you learned like solving system of equations before in your previous math class? If yes, raise your hand. No, not many. Okay. Oh, attendance. Here. All right. So review of linear system and their graph interpretations. So suppose we have two linear equations. Together, they make a system of linear equations. Okay, and you know each linear equation, it corresponds to a line on the xy plane, right? Everybody? Linear equation corresponds to a line on the xy plane. And so here we have a system of two linear equations. And this is also called a linear system. All right. An order paired AB is a solution of the system if both equations become true statements when A is substitute for X and B is substitute for Y. Then we say AB satisfy the system. So true statement means you plug in your X equals to A and plug in your Y equals to B, and then you get your left hand side equals to the right hand side. So this is a true statement. Okay, everybody? So let's look at example 1. So here we have the system. Determine if each of the following order pairs is a solution of the system. Okay, part A, 0, 3. So this means x is 0 and y is 3. Right, everybody? Let's plug in the first equation. X, what is x? 0. And what is y? 3. Is it equal to the right hand side? 3. Is this true? Yes. Good. So this also means the point 0, 3 is on the line, the first line. Right, everybody? Okay, let's plug in the second line. X is what? 0. Right? And then minus y. Y is 3. Is it equal to the right hand side -1? No, it's -3. Oh, this means this point is on the first line, but it's not on the second line, right? So as long as it's not on the second line, then it is not the solution of the system. Okay, everybody? Yeah. To be a solution of the system, the point must be on all the lines in the system, right? If it's not on one of the lines, then it's not a solution. Okay, thank you. Part B, 0, 1. So x is 0, y is 1. We plug in the first equation. X is 0, y is 1. Oh, is it equal to 3? No. Oh, then do you need to look at the second equation? No, it's not on the first equation, then it's not the solution of the system. So we don't need to check the second one. The first one is not on it. Then we just say no, it's not solution to the system. Okay, and here x and y, x plus y, so 1 plus 2, is it equal to 3? Is it? Yes. Okay, let's look at the second equation. X is 1 minus y is 2. Is it equal to -1? Yes. Oh, you see, this point is on both of the lines. Therefore, yes, this is a solution of the system. Okay, and in terms of the picture, okay, we know that linear equation, it corresponds to a line, right? So we can graph the linear equation. And a solution of a system corresponds to a point that lies on both of the lines. In other words, solution of a system corresponds to the points where the lines intersect. Right, everybody? So intersection points. Okay, so now we have those two lines, two linear equations, and we know 1, 2 is a solution. And how can we tell if this is the only one? Okay, let's grab those two lines. Do you remember we have several ways to grab a line? One way is use the slope intercept form, right? You put the y-intercept first, and then you look at the slope. The slope is rise over run. So you go some unit and go up or go down some units to get a second point, and then you connect 2 points to get a line, right? So this is using the slope intercept form. The second method is plot the x-intercept and y-intercept. How do you find the x-intercept? X-intercept, so it cross the x-axis, right? It means the y coordinate is 0. So you set the y equal to 0 and you solve for x. That gives you the x-intercept. And then how do we find the y-intercept? Yeah, set the x equal to 0 and solve for y. Right, everybody? Okay. Which way do you want to do here?
Yeah, we get your slope intercept because slope intercept is y equals mx plus b, and we don't have b.
Mm-hmm. But you can solve for y to change to slope intercept form. But like, which method do you prefer? Slope intercept. Okay. All right. So intercept form, you get y equals mx plus b. So you want to solve for y. Okay. Equation 1. Solve for y. Well, what do? You subtract x on both sides, right, everybody? Yes. So we get y equals, minus x plus 3. Therefore, the y-intercept is what? 0, comma 3. Yes, everybody? So x-intercept or y-intercept, they are points. Okay. So 0, comma 3, this point. And what is the slope? -1. You can think of -1 as -1 over 1. So this is rise over run. So it means, okay, we're at this point. Run is go to the right 1 unit. Okay? But you rise is negative. It means you go down 1 unit. Yes, everybody? So therefore, we go to the right 1 unit and go down 1 unit. We're right here. So, and we connect them. So 2 points can fix a line. Okay? You can use your student ID to draw the line. Or a credit card. Okay. So this is the first one. Right, everybody? Okay. The second one, you can also solve for y, and then also do the points slope intercept one. But how about I use the x and y intercept method? Then you can review both methods. Okay, the second line. Let's use x, y intercept method. So look at the second one. To find the x-intercept, you set what? Y equal to 0, and we solve for x. If y is 0, what do you get? You get x minus 0 equals minus 1. So what is x? Okay, so you get x is -1, right, everybody? So x is -1. So your x-intercept is -1, comma 0.
Would it be wrong to set to do the slope intercept form like that and set the y equal to?
Yeah, you can do slope intercept form.
Wouldn't it be 3 then if we use slope intercept form?
Here. So is it
Oh,
form?
yeah, never mind.
Oh. Okay, yeah. All right. So x-intercept is -1, 0. How about the y-intercept? You said what? X is 0. And we solve for y. Okay, x is 0. You see? 0 minus y equals -1. Ooh. Yeah, y is just 1. What is your y-intercept? Your x is 0 and y is 1. So 0, 1 is right here. Okay. We connect them. Okay, do you see this line, everybody? Mm-hmm. All right. So this is two methods to graph the line. Oh, can you see we only have one intersection, and this is the point 1, comma 2. And we already checked that. This is the solution of the system.
So, in order to check our answer,
Oh, okay. This
oh
is
yeah, oh sorry. In order to check our answer for example 1, we do this.
You don't need to do this.
You don't need to.
You don't need to. I'm just talking about how to verify a point is a solution. And then I'm talking about how to graph the linear equations and see the intersection points. But this is not the formal way how to solve the system. Okay. Yeah, we will talk about later what is the formal algebraic way to solve the system. So far, so good, everybody? All right. Okay, so the practice, do it at home. And you can see here, proof of them are like solve intersect form, then it's better to use the solve intersect form to grab the lines. Okay, so keep going. Now, how to solve the linear system algebraically? I'm going to teach you two methods. Okay, one method is called the substitution method. And the other method is called the elimination method. All right. So this is how it works. Substitution method. You compare both equations. You solve one equation for x or for y. And which one to take? By the way, there are so many different ways to solve the system of equations. And you want to find the easiest and fastest way. Okay, so how do we think? We want to pick an equation and solve for x or y. For example, here, you compare all the coefficients. Look at the first equation. The coefficient of x is 3. The coefficient of y is 2, right? And the second equation, the coefficient of x is 2, and the coefficient of y is 1, right? So when you solve for x and you solve for y, think about if you solve for x, what do? Okay, you move the 2y to the other side, and then you divide it by 3. So you have fractions, right, everybody? And if you solve for y, what happened? Okay, you move the 3x to the other side, and then you divide it by 2. Do you see you also have fractions? Yes, everybody? Okay, but how about the second equation? Do you see the coefficient of y is 1? When you solve for y, you just both sides subtract 2x, and you don't have fractions. Do you like to work with fractions? No. They actually increase difficulties, and it's very easy to make mistakes when we work with fractions. We're not familiar with fractions. That's why, even though there are so many different ways to solve a system, you compare all the possibilities and pick the easiest and fastest one. Okay, so try your best to avoid working with fractions. Okay, everybody? So, therefore, compare all the coefficients, and then we realize taking the second equation and solve for y, that's easier. Okay, and then what do? You substitute the expression we get from x or y and plug it into the other equation. This will make an equation with one variable. Okay, so we have equation with only one variable. And then we can solve for that variable. And after that, you can find the other variable by plugging it back into the other equation. Okay. So example 3, this one is easy. I will let you to do at home because your equation 1, you already get y equals to something, right? You already get y in terms of x. Then you just directly plug into the second equation. So this example is easy. let's do this example together. So my requirements, when you show your work, label the equations. So this is equation 1, that's equation 2. And you put the circle, okay? Because if you don't put the circle, it looks like, oh, 1. What do you mean by 1? Do you multiply by 1 or do you multiply by 2? So please put a circle around the number to indicate. This is equation 1. That's equation 2. Okay, so from equation 2, we want to solve for y. So that means, how do you solve for y? You subtract 2x on both sides. Is that okay, everybody? And then you get y equals negative 2x plus 1. Okay, so we compare all the coefficients. We pick an equation and we solve for y. Yes, everybody? All right. Now, substitute the expression we get from here into equation 1. So we plug in equation 1. So equation 1, 3x plus 2y. But instead of y, we put here negative 2x plus 1. Parentheses equals 4. Okay, let's substitute 3x plus 2y. But what is y? Plug in negative 2x plus 1. And please don't forget the parentheses, because many mistaken students forget about the parentheses. Everybody say parentheses, parentheses, and then equals 4, right? Do you see we get an equation with only one variable, right, everybody? We know how to solve equation with only one variable, right? Okay, what do we do? We want to combine like terms, right? But before that, you need to distribute. So we have 3x, and then what? 2 times negative 2x is negative 4x. And then plus 2 equals 4. Combine like terms. What is 3x minus 4x? Yeah, negative x. Plus 2 equals 4. Okay, what do we do next? Subtract 2. Then we have minus x equals what? 2. Oh, what's next? Divided by negative 1. So we have x equals negative 2. Yes. Alright, so this is what it means. It makes an equation with one variable, which we can solve for x. After you find the x, plug it back. Alright, so okay, let's call this 3. So now we plug it back to 3. Y equals negative 2. Right, everybody? Y equals negative 2. What's x? Negative 2. And plus 1. What is negative 2 times negative 2? 4. 4 plus 1 is 5. Oh, so our solution is x is negative 2 and the y is 5. So this is our answer. Okay, so this is our x and this is our y. Okay. So this is the substitution method. You compare, okay? You compare both of them. and then you see, okay, which one, the coefficient is 1. Well, then you can solve for that variable in terms of the other variable, and then you substitute, plug into the other equation, and then you get one equation with one unknown. You can solve that unknown, and then you plug it back to get the other unknown. So this is a substitution method. So far, so good, everybody? It's useful when you have one of the coefficients 1. Okay, because then you can avoid fractions. What if all the coefficients are not 1? In that case, I suggest you to use the other method called elimination method. Okay, so elimination method is good that when you have all the coefficients, they're not 1. Okay, so let's look at the steps. Here are the steps. You write both equations in the form of ax plus by equals c. Do you see here we already have this form? Yeah, this is the general form of linear equations. And then use multiplication to make the coefficients of x or y add up to 0. Okay? And then add the equations together. After this, one variable will be eliminated. Okay? This makes the equation with one variable which we can solve. Okay. So look at this problem. What does that mean? Okay, you want to compare the coefficient of x and the coefficient of y. Which one are easier? The coefficient of x is easier or coefficient of y is easier? X, right? 3, 2 is easier than 4, 5. Do you agree, everybody? So we want to make their coefficient to be the same. Okay, in order to make them to be the same, it involves something called the least common multiple. Okay, everybody? So you have 3 and 2. What is the least common multiple of 3 and 2? 6. Okay, everybody know what's the least common multiple? It's multiple and it's the smallest one. So yeah, LCM 3, 2. What the multiple of 3? Okay, 6, and 3 times 3, 9, and then 4 times 3, 12, and bigger ones, right? And then multiple of 2, 4, 6, 8, 10. Least common. You see, common is the 6. 6 is the least common. And how about the next common? 12. But you're looking for the least. So that's why this is 6. Is that okay, everybody? How about least common multiple? Oh, sorry. I have online students, so I'd better use my draw it here. Okay. All right. Let's see. Okay, so we're talking about least common multiple, and we compare the coefficient of x and y. The coefficient of x is easier, so that's why least common multiple of 3 and 2 is 6. Multiples of 3, they are 6, 9, 12, and bigger one. Least common multiple of 2, the 2, 4. 6, 8, 10, 12, and the common one are the 6 and the 12, and the least one is the 6. So this is how we find the least common multiple, which is 6. Okay, now this is equation 1, this is equation 2. So we want to get 6x. Equation 1, how do we get 6x? We multiply by what number? 3 times one number, you get 6. 2. So equation 1, you multiply by 2. All right, how about you guys take turns to answer my questions? Diana, 3x times 2, you get what? And 4y times 2? 4y, the next term. 4y times 2 is 8y. How about the right hand side? So we multiply this equation by 2. How about the right hand side? You multiply by 2. What do you get? 4. Yes. Okay. This is the first equation, and we call this is equation 3 for this new one. Okay. And then the second equation, what do we want to multiply? Haley. So we have 2x, right? How do you get 6x? Times 3, right? So when you multiply by 3, what do you get? 6x, 15y equals negative, negative 3. We call this equation 4. Do you see 6x, 6x, they're the same? So we want to use one equation to subtract the other one. Nikema, tell me. Do you want to use equation 3 minus equation 4, or you use equation 4 minus equation 3? Yes. Why? Yes. Then we will get positive coefficients, right, everybody? We like to work
the other way around.
We can work with the other way, but it's bad to work with negative coefficients because okay, but this is okay, but for like inequality, when you divide by negative number, it's imperfect. So that's why we try to reduce the chance of making mistakes, and we love to work with positive coefficients. Okay, so it came out. We use equation 4 minus equation 3. So that's my notation. Okay, everybody, you must write this notation. Show me your work. This is the requirement, how you show your work. Put the circle to indicate this is the equation. And then this number means you multiply the equation 1 by 2. Okay, that's why this has the circle. This does not have the circle. It means you multiply by 3. Is that clear, everybody? Okay, it came out. 6x times 6x minus 6x is 0. 51 minus 8y. 7y equals negative 3 minus 4. Negative 7. Oh, what is y? Negative 1. Aha. See, everybody? This is elimination method. You eliminate one of the variables. So you get one equation, one unknown. Okay, everybody? All right, so now you can plug in. Okay, Jackson. Now we plug in one of the equations to find the x. Which one is easier? So which one do you want to plug in? The first one. Okay, if you plug in the first one, what do you get? 3 times. You plug in the first one, you replace y by negative 1. So what do you write? Yeah, so 3x plus 4 negative 1 equals 2, right? Okay. So you get, oh, you see this is negative 4. What do you do? Ethan, what do you do? How do you solve for x?
Add negative 4 over 2.
You mean add 4?
Oh.
Oh,
yeah, add 4.
Yeah, add 4.
Yeah, sorry.
No problem. Then you have 3x equals what?
3x equals 6.
Yes. What's x? Yes. You see? We get x is 2 and the y is minus 1. So this is the solution. Okay, so this is the elimination method. You use, usually I like elimination method better. I like, but you can use either one. Okay, but the substitution method, it works better if you have a coefficient is 1. Because if the coefficient is not 1, you will need to work with fractions. And it's very easy to make mistakes when we work with fractions. Okay, everybody? All right. So keep going. Okay. are you able to see what's on yours? Oh, okay. So this is what? 7. And this is it 5? And how about the second one? Okay, thank you. All right. Now, what happens if we have fractions? Well, the first thing you do is carry out other fractions. Look at the first equation. How do you carry out the fractions? Yeah, multiply by 2. So Peter, when you multiply by 2, what do you get?
7 plus x plus 5y equals negative.
Yes. Good. David. The second equation, if you want to carry out the fraction, what do?
Wouldn't you just multiply by 3?
Yes. Then what do you get?
You'd get 3x plus.
Oh, when you multiply by 3.
Oh, so it'd be 9x
Mm-hmm.
plus 2y equals 3.
Yes. See, everybody? When you see fraction, just carry out fraction first. Now you can solve this. Okay, now it's your turn. Solve this. Okay, so compare the coefficient. Which one do you want to eliminate? The y. And what is the least common multiple of 2 and 5?
Oh, okay.
Oh, and remember your steps, right?
Yeah, I did this before you started doing it.
Oh, okay. Yes. Yeah, label. Which step, what you're doing. Every step, label them.
None of my tries give me 0.
Oh, okay. What are the possible routes right now?
If possible, are like 1 plus 4 equals minus 1 equals 3 minus 1. Do I need to try to use algebra?
Yeah, all the, but are you so show more work, like plug-in. So plug one is
Because
good 5 times.
Is minus 5. Here it's positive.
Are you talking about the 1 or the -1?
The -1.
Mm-hmm.
So like negative. So it's always negative. Here.
Mm-hmm. Mm-hmm. Yes.
It will always be negative.
Mm-hmm.
So minus 2. So this is impossible first.
Mm-hmm.
For positive, just click and negative and plus and plus. It doesn't match either.
Mm-hmm.
And then I try for this. Impossible as well. This is negative 4. This is negative 4.
Yeah, maybe write out more work here.
Okay.
Mm-hmm.
But so do I need to try for these fractions as well?
Usually, you don't need to try the fractions. Usually, the integers, you should get the roots.
Yeah, I tried those +1 -1 +2
Yeah.
We have a question.
Yes.
Go.
This should be the same thing. Okay. Here. Okay. So you get F3, 4, and then 3. Oh, so the X. Oh, yes, it is the X. It's negative. So negative. Oh, yeah, so it's 4 minus 3. So 15 minus negative becomes positive. So 15 plus. Yes. Let's check our answers together. Okay. So. Oh, I totally forgot to talk about the quiz. Okay. That's so important. You need it on the Friday. Okay, so let's talk about the quiz first. The first problem, you want to isolate the exponential term and then apply log, right? So how do you isolate? Move the 13 to the other side and then divide it by 8. And then this is log base 4, so you can apply log 4 on both sides. Or you can apply ln on both sides. But if you apply ln on both sides, the left-hand side becomes 5 minus 2x times ln of 4. That's why the next step is 5 minus 2x equals ln of 7 over 2 over ln of 4. And this is exactly the change of base formula. And then you get the answer is 2.048. And the second problem, you divide. See, subtraction, it means divide. Addition means multiply. So here you divide and you get both sides. Get rid of the log, you both sides raised to the 3 to that power. Therefore, you get this equals to 27 and clear the denominator, distribute, combine the x, and solve for x. So I also write down your mistake here. Okay, so you might not have time to see the mistake. Please check online. Okay, you can find the quiz mistakes. So learn from the mistake. Don't make this mistake again in the exam. Okay. Yeah.
It's working.
Oh, okay.
I think I got marked off or something. Could you see what that was?
Oh, so do you remember?
I think you passed it. It's like somewhere right there.